All right, next up in our generative design category, coming to us all the way from Frankfurt, Germany, is Jacqueline. Hello. So Jacqueline just graduated from the University of Munich, and you may know her. She's kind of famous because she has 10,000 followers on YouTube as that BIM Girl. She has a great channel where she does tech reviews and gives tech insights and has a ton of fun. So today she's going to share some of her work with us, and we're super excited. So take it away.
Yeah. So, good evening, everyone. I'm going to talk a bit about my master's thesis that was on the topic of design optimization in early project stages. So essentially how we can use generative design for project development. And so when people talk about machine learning, what they usually mean is artificial neural networks. But there's this whole other side of machine learning that is evolutionary algorithms or genetic algorithms. And that is what we use for generative design studies. And the cool thing about them is they mimic the natural processes of evolution. So just like in nature, through mutation we get different variations of genes, and then through natural selection, those that don't perform that well, those that aren't adapted well, they get ruled out and the other ones prosper. And and the way that works in computer science is we have an algorithm that generates a bunch of different design solution options and then measures how well they perform, and then those that perform well make it to the next generation and are developed further. So at the center of every generative design study, you need a parametric model that is parametric in all the aspects that you don't know about your design and that you want to determine. And then on the other side, you have the design goals. So this is the objectives, the direction that you want the optimization to go, so what you want to achieve with your design. And for my master thesis, I was able to use data from Siemens, and they have this architectural standard called construction excellence, with which they build all of their offices all around the world. And so this is what a standard layout looks like in their offices. And to transform that into a parametric model, I identified that there are basically 3 different kind of modules, and there are some rules of how you can combine them to create an office. And so the goal was to have the project developer input the site outline and tell the algorithm how many people he wants to accommodate in the office, and then use Refinery to find like the perfect combination of like where to put the office and which orientation, how big and how tall to make it, and how densely to pack the actual desks in the office. And so once we had the parameters defined, you need to define the other side of the parametric model. So what do you actually want to achieve with your design? And if once you've found the design goals, you need to pair them with indicators that are actually calculatable and measurable, so that you can compare the designs to against each other on an objective number level to figure out which perform better than others. And then on the software side, this looks like this. You prepare the parametric model in Dynamo, and then you can use Revit, which is an add-in for Dynamo, to start the evolution. And it will provide you with this nice UI where you can search through all the different designs that it generates for you. And to make that possible, you have to give Refinery access in your parametric model, and then it can start switching around the parameters and setting them to different values and detect the outcome that they produce. And that way it can learn in which direction to go. But then the big problem is if you have multiple objectives that are also maybe kind of contradicting, how can you even say that one design is better than another? And so this is where the concept of non-domination comes in. Because you essentially want to find all the solutions that are on this Pareto front, so that are not dominated by any other solution that has better performance metrics. And then the algorithm that Refinery uses is called NSGA2, and it's actually quite fascinating. So if you're interested in like computer science and algorithms, I recommend you to look into it because I think it works quite beautifully. But since I only have 20 seconds per slide, I cannot really explain that much. So then the last thing before I could start the optimization was I had to decide what population size I was going to use. So how many different design options are generated per generation, and then also how many generations you wanted to go for. So what have I learned from my master thesis? The most important thing is that you choose the parameters but most importantly the design goals very wisely, because that will determine the kind of results you get. And then I kind of started to struggle with the term generative design a little bit, because it makes it sound like the computer had some inherent creativity and was really coming up with design ideas. But while actually it is still the human designer who has to develop this abstract concept of the design and then span up the solution span, and the algorithm merely helps like finding the best combinations of values. But it's still very useful, and I think the whole concept is very fascinating, and it brings your designs down to like this comparable level. And so if you're interested in reading it, my master thesis is actually online. You can find it if you go to that link or scan that QR code. And if you want to stay in touch, you'll find me on various social media platforms. Thank you.
Thank you, Jacqueline.